All right, so let's take a look at number three. Number three. I think this one's probably a little easier, actually. Okay. All right, so we got, it looks like resistor D is in parallel with the battery to begin with. So that, again, it's like a tall waterfall, a splash, something like that, straight back to the battery. Okay. But then the current splits off and goes CBA. So it's like clunk, splash, clunk, splash, clunk, splash, right, and then routes back again to the battery, the pump, the battery. Right? Okay. So there's your waterfall model. Right. Again, I gave you each individual resistor, and I gave you the voltage supplied by the battery. Okay. So let's do same process as before. I'm going to redraw that circuit and then find some equivalent circuits and then work my way from there. Okay. So I have a 9-volt battery on my paper. I've got resistor D is 9 ohms. Resistor C, I've got 10 ohms. Resistor A and B are 4 ohms each. Okay. Of course, this is just my paper. Numbers are probably different on your paper. Okay. So remember the process. I'm going to find my voltage source, fly over to the complete opposite side of the circuit, and work my way back towards the source. These three. Guys, are those series or parallel? What is that? Who says series? Series? Yeah, series. There you go. Yeah, series. So can I just very simply add those together? 10 and 4 and 4. That's like 18 ohms. 18 ohms resistance equivalent. Right. Then I'll go ahead and redraw the circuit. It's got my 9-volt battery still there. Got 9 ohms here. Right. And these three amigos together is kind of like one giant 18 ohm resistor. Okay. Then back towards the voltage source, right into this guy. Now, these two resistors, series or parallel? Who says series? Who says parallel? Parallel, parallel. Right. Can I do product over sum? Right. So resistance equivalent is 9 times 18 over 9 plus 18. Number of ohms. Ooh, I hope I'm going to get a whole number out of this because I try to make almost all these come out to whole numbers. And 18 is, so, right. Oh, yeah, 6 ohms. 6 ohms. Right. In fact, that's the, if I drew one more equivalent circuit, it would just be the battery and the 6 ohm resistor. Right. So that is the equivalent resistance for the entire circuit. I just found it. So my paper at 6 ohms. Hopefully you found yours too. Right. You guys got that? Right. Next column, voltage drops. And remember, this was kind of the trickiest one for last here. But you know what? This resistor D is just I see this waterfall is the same height as the pump to begin with, right? So the fact that I have a 9-volt battery up, do you guys think 9 volts down? Isn't that Kirchhoff's loop rule? 9 volts up, 9 volts down, 9 volts up, 9 volts down, right? Resistor D is just going to match your battery, which in my case happens to be 9 volts. Can you guys just copy paste that number right there? And you guys see why, right? Right now, CBA. Ooh, now we're going back to, I got a bunch of resistors along a series branch, and the voltage drop across each one individually is just proportional to that resistor. Right? All right, you guys ready to do that? All right, so actually, I guess I can use my original circuit here. All right, switch out to PP as I did it before. Some color consistency. Right? And I know from this point to this point is 9 volts drop. Right? So what's the drop? So delta V, voltage drop, how do you do it? CBA, I think. So C, okay. I got a 10 ohm resistor is resistor C. So this is my resistor C, this is resistor A, this is resistor B. Okay. So C, I got 10 ohms out of 10 and 4 and 4 is 18 ohms. And I know the total voltage drop is 9 volts from this point to this point. It's 9 volts. Okay. You guys figure out on your paper what this is going to correspond to? Right. Let's say it again while you guys are figuring that out. Right. Okay. So I got a 9-volt battery. I know from this point in the circuit to this point in the circuit, there's going to be a 9-volt drop. Right. 9 up, 9 down, 9 up, 9 down. Right. So from here to here, right. Remember, voltage is kind of like pressure. Right. So pressure drop, or the waterfall model, it's like cliff height. You can think of it that way. The higher the cliff, the higher the pressure. Okay. Right. So it's going to, along this branch, the voltage drops a little bit, a little bit, a little bit, but collectively it has to drop 9 volts. Okay. But each individual drop is just proportional to the resistor that's dropping across. So I've got this 10 ohm resistor, so I put 10 ohms. Out of the entire branch is 18 ohms, right? 10 and 4 makes 18. Right? Well, I found that out before anyway. Right? So 10 out of 18 is the fraction, the proportion, right? Of what? Of 9 volts. Okay. So what's 10/18 of 9 volts? And that's 5 volts. Okay. So 5 volts for me dropped across resistor C. Okay. So I'll go over to resistor C and write in 5 volts. Okay. Okay. Now resistor B, let's do it. What's the voltage drop? Right. Well, I got 4 ohms is resistor B. Now it's on the same branch, so it's going to have the same denominator as before, 18 ohms. It's on the same branch. Okay. And we're considering the same total voltage drop, 9 volts. Right. So that's the same as before. Right. Right. But now we're honed in on this resistor B, which for me happens to be this 4 ohm guy. Okay. So that's going to be, what's that? 2 volts, I think. Is that 2 volts? Right. And then the voltage drop across A, right, is this guy, which for me happens to be the same math. Right. So 4 ohms again on the 18 ohm branch of 9 volts is 2 volts. Okay. Okay. All good? All right. So over here, I got a 2 volt drop and a 2 volt drop. Okay. Let me make sure that that matches up with my waterfall model. Okay. So I've got this battery pumped up 9 volts. Think about that being like this total cliff is like 9 meters high. Think that way. Okay. And then this waterfall, that's waterfall C, dropped 5 volts. And then this one, 2 volts. And this one, 2 volts. Oh, guys, what's 5 plus 2 plus 2? That's 9. Look at that. Right. So that satisfies Kirchhoff's loop rule. Right. Any loop has to zero out. And it does right here. Right. Up 9 volts, down 9 volts. Up 9, down 9. Up 9, down 9. Right. Is that? Right. You guys get so far? Right. All right. You guys ready for Ohm's law? Ohm's law. So current is voltage drop on resistance. Right? So across resistor D, I got 9 volts on 9 ohms. Guys, what's 9 volts divided by 9 ohms? That's 1 amp. Okay. Next row, what's 5 volts acting on 10 ohms? 5 over 10. Ooh, that's 0.5, right? That's as crazy as they get with decimals on this page. It's like 0.5, right? It's the craziest decimal you see. Right? Right. If you get like 0.3 or something, then that's not something I would have done. Right? 2 volts divided by 4 ohms is 0.5 amps. 2 over 4, again, it's 0.5 amps. Right? And then at the point of the battery's supplying 9 volts. It feels like it's pushing against 6 ohms. Divide that out, that's 1.5 amps. Okay? Right. Let me go back to my model and make sure that these numbers also make sense. So the battery's supplying 1.5 amps. Think of that sort of like 1.5 gallons per minute. Right? Immediately that current splits. And across resistor D is 1 amp. So I had 1.5 amps leaving and 1 amp split and went this way and then back, which leaves a half an amp to go the other way, which is exactly what my numbers say. 1 amp went one way, the other half amp went down the other way. Right? Everybody good? Right. You guys ready for Joule's law? Right. So you can pick your favorite version of Joule's law. Here's 3 different perspectives. I'm just going to use current times voltage. Okay. So current times voltage I'm going to use. Let's go 1 amp times 9 volts. That's 9 watts. Half an amp times 5 volts. That's 2.5 watts. Half times 2, that's 1 watt. Half times 2 is 1 watt. Okay. Okay. Now near the end. So this very last cell, let's do 2 perspectives and make sure that those perspectives converge to the same answer. Okay? So I could apply Joule's law at the point of the battery. What's 1.5 amps times 9 volts is 13 0.5 watts. Okay. And the other perspective is, does electricity supply match electricity demand? Let's see if it does. So I got 4 resistors all demanding some like joules per second. Okay. So what's 9 watts plus 2.5 watts plus 1 watt plus 1 watt? Right. So that's the electricity demanded. It is 13.5 watts are demanded, and the battery 13.5 watts supplied. It matches. Supply matches demand. Okay. All right. Let's get that.